Hey everyone, if you're looking for a research area, today's long video is for you. In one of my previous episodes, I talk about how what you learn in class often doesn't capture the full scope of modern innovations happening in the real world. The material covered in coursework rarely reflects the latest research and groundbreaking discoveries being made right now. So, if you're an undergraduate, a master's student, or even a high schooler, how do you go about choosing a research area? Which research community should you follow? How do you know if you'll actually enjoy the field? And more importantly, how can you be sure you'll be able to contribute? These are big questions, and figuring out where to start can be overwhelming. Now, there's no universal formula that works for everyone, but I do have a few strategies that might help guide you through the process. And of course, if you ever have your own thoughts or experience, feel free to share them in the comments. I'd love to hear them. I would like to start with one philosophy on how you should think about this. Emotional decision versus informed decision. What do I mean by this? Well, do you remember when you were a high school student and you need to pick or declare a major? It felt like a huge decision, right? Now, here's an interesting statistic. According to one article, 61% of college graduates would change their majors if they could go back. This is a huge number. It's like many of them didn't go through a proper process in choosing the right major for them. Now, I understand this is a sensitive topic because no one has a crystal ball to see the future. But nevertheless, it is an interesting number. It suggests that many people may not have had the right tools or approach when making such a crucial choice. We maybe were making an emotional decision. So let me explain. But think about it. When you're in high school, you're only exposed to a handful of subjects: math, science, history, maybe about 10 to 20 core subjects. But when you step into college, suddenly the number of options explodes. How many majors are available in college? Any guess? 2,000. Well, that's what Google said. 2,000. But let's be realistic. Let's go to a university website. For example, here I have University of Illinois from my state, the state of Illinois. There's about 400 majors, right? There's even a download button where you could export the list into an Excel file. So we're talking about a huge gap here, 10 to 20 high school subjects versus like 400 possible majors, right? So this is what we found. So what typically happens here? We likely choose a major or a direction based on what we already know. We maybe think, I like math in high school, so I'll major in that. Or physics was interesting, so that must be my path. Or I'm a fast programmer, so maybe I should go to computer science. I want to be clear here, there's absolutely nothing wrong with these majors. They're just examples. But here's the thing, what about fields that never even came up in high school? Majors like supply chain management, urban studies, biomedical engineering, or game design. According to Google AI, there are many areas that rarely get discussed in high school classrooms. And that's the real takeaway here. There's a massive gap between what we were exposed to and what's actually out there. Likewise, when we decide to enter research, we face the same challenge. You might take only 10 to 15 computer science classes, but out there, the landscape is vast. Hundreds and hundreds of conferences, journals, and hundreds of research specializations. For example, here from my department website, although there are a lot of CS classes, you know that for your requirement, you might only take 10 to 15 of these classes, right? But however, in real life, again, there are hundreds and hundreds of conferences. For example, from this Wikipedia, right? You could just scroll down and you could find at least over 100 conferences. And I bet there are more that are not listed here. So it's easy to feel lost. So how do you approach this decision-making process? I would like to propose a simple three-step process: eliminate, expand, and then narrow. First, start with the game of elimination. The goal here is to filter out areas you know you don't want to pursue and identify the ones that naturally draw you in. But how do you decide? You could consider factors like which classes you truly enjoyed, what kind of activities excite you, what topics keep coming to mind even outside of class, and which areas you find yourself reading about beyond just the required textbooks. Asking these questions can help you refine your focus by eliminating the paths that don't align with your interests. Let me share you my own experience. About 20 years ago, computer science was primarily divided into two major pillars like AI/ML/theory and then systems. Today, the field has expanded a lot to include areas like robotics, human-computer interactions, and more. Right. So back then, I enjoyed my algorithm classes, for example, but I never felt motivated to read more up, outside of the coursework. I remember a friend proudly telling me he had finished reading the Nuth books. If you finish reading these books, it's like a major accomplishment. I gave it a shot and completely failed, right? So that was my signal. Theory and algorithms wasn't really for me, so I've shifted my focus towards systems. Once I chose systems, I need to perform more elimination within the systems area. In my coursework, I already took every relevant classes like functional languages, compilers, computer architecture, VLSI, embedded computing, databases, networking, and operating systems. From there, I began to eliminate more. I found myself gravitating towards databases, networking, and operating systems, so I eliminated the rest. At that point, I wasn't overly picky. Any of those three areas would have been fine for me. But what ultimately made my decision, I love the projects in my operating systems classes. I enjoyed designing systems, debugging, and troubleshooting, and that's what pushed me toward finding an advisor in that field. So if you're trying to figure out your own research path, starts with elimination. Now, let's talk about the second step, expand. And before we dive in, I have to confess, I actually skipped this step when I was figuring out my own research area. Back then, resources like this channel didn't exist to guide me. Luckily, I happen to enjoy operating systems, but if I had to follow this process, I would have had much a clearer picture. So what does expand mean? It means expanding your understanding of the field and doing it like a spy. Think of intelligence agencies like the CIA or even like the James Bond's, MI6 here. Their job is to gather as much information as possible, whether it seems useful at the moment or not. That's exactly the mindset you need to adopt here. How do you apply expand to research? Start by heading to csrankings.org and looking at the acronyms of research area that interests you. Let's say you're considering, again, networking, databases, and operating systems. Click on each one of them, and you'll see the top conferences in those fields, like, again, SIGCOMM and NSDI for networking, SIGMOD and VLDB for databases, OSDI, SOSP, Eurosys, FAST, and ATC for operating systems. Remember or write down those acronyms. Next, go to dblp.org and type in one of those acronyms. Let's say SIGMOD here. I type it in the search box. Instantly, you'll see hundreds or even thousands of paper titles, right? Here again, let me just keep scrolling down. Hundreds and hundreds of paper titles. You could do that for other conferences like, SOSP, SIGCOMM, and so on, right? Years and years of paper titles. So now here's the trick. Skim all paper titles. Just the title, not the paper. Reading one paper title, just one title, should just cost you 5 seconds. Go through about 500 to 1,000 titles across multiple years and conferences. That might sound a lot, but let's do the math. 1,000 paper titles at 5 seconds, that's about 5,000 seconds, or a little bit under 2 hours, right? But don't try to do that at once. It will be very, very boring, but maybe spread it out over 1 week. So now at first, you'll feel overwhelmed with this information overload. You saw new terms, buzzwords, and concepts that you've never heard of before, and they will start flooding into your brain. But that's the point. Your perspective will begin to expand. Now, ask yourself, does this field intrigue you? Do you feel drawn to this research community? And if the answer is yes, or partially yes, you are on the right track. Next, we're not stopping at paper titles. We need to go deeper, and this is where you move from paper titles to downloading the paper and reading the abstracts and introductions. Let's take OSDI here as an example. If you found, operating system is interesting in your first pass, now it's time to download the real research papers. So again, I would go to Google, type, for example, OSDI 2024 technical program, it will bring me to the OSDI 2024 technical sessions. Here you could, again, thank you for Usenix for allowing all papers to be publicly accessible. Here you could download the proceedings, or again, you could go click every paper here. You could click the paper title. It will bring you to a page like this, right? And then here you could download the PDF for that file, right? So for example, you download that and you're gonna get something like this, right? Okay, so that's the idea. Again, you want to download all the papers from the conference that you want to dive into. You'll end up with a single document like this, a long PDF file containing just the abstracts and introductions. In my research group, we call this the two-pager PDF file. We have a bunch of them: OSDI, Eurosis, SOSP, ATC, FAST, and so on. Print it out or save it to your phone and start skimming bit by bit. By doing this, you'll quickly get a sense of what's trending in the field, what problems are the researchers focusing on, what's considered important right now, where's the field heading in the next 3 to 5 years. You will start recognizing different types of research papers. Some focus on immediate practical challenges like system debugging, while others aim for long-term breakthroughs like a 5-10-year mission to explore strange new worlds, to seek out new life and new civilizations, to boldly go where no man has gone before. Well, that's what Captain James T. Kirk would say if he's a professor. Here I use a generative AI to combine James T. Kirk and Einstein here, and this is what they give me. Anyway, you could choose which research style fits you, long-term or more pragmatical. My research tends to be a more practical one. I'm not Captain Kirk here, right? But bottom line, you'll start seeing the big picture. You'll develop an instinct for the field, and hopefully it will excite you. Your curiosity will kick in, and hopefully you have a powerful feeling for the community. At this stage, I recommend skimming about 50 to 100 papers. For each paper, just read the first 2 pages. Again, do not read the entire paper yet. I repeat, do not read the entire paper yet, just the first 2 pages. And if you're worried about not understanding them, don't be. Of course you won't understand most of it. You're new. So that's normal. Keep going. If you commit to skimming just like 3 papers a day, like morning, afternoon, and night, within a month, you'll have a completely new perspective on the research landscape in your community here. You could do it faster too if you skim more papers every day, and maybe you could finish it in 1 week. The final step, the third step, is to narrow things down. Now that you're overloaded with information, it's time to refine your focus. Just like the intelligence agencies that shift through vast amounts of data to make a few critical decisions, you now have a broader perspective on your research community, but now it's time for you to narrow in on what truly interests you. Out of those 100 papers you skimmed, I would say pick 10, right? And this time read the entire paper from introduction to evaluation. But how do you choose which 10 papers to narrow down? There are a few approaches. One way is to select papers from professors who are still active doing research in your own department. For example, here is a list of professors in my department. This way, you could identify potential professors to work with. For example, if there are 3 to 5 operating system professors at your university, you might want to dive into their specific research areas of concentration and read their papers. Another approach is to focus on papers that provide open source code and reproducible experiments. How do you find those papers? Look for reproducibility badges on upper right of the paper. Associations like ACM and Usenix award these badges to papers that make their code and experiments publicly available. For example, again, here's for ACM, and here's another like for Usenix. They have slightly different shapes of badges. Why does this matter? Well, if the source code is accessible, you could download the paper, you could download the experiments, analyze it, and understand this code, how the authors designed and implemented their work. You could modify it, experiment with it, and see their systems in action. And here's one more thing. Today's computer science research, I would say, is more collaborative than ever, spanning institutions across the world. Because why? Because open source, open data, and open publications have made it possible for students, researchers, and professors from all around the world, all around the institutions, to collaborate remotely together in many different projects. Now let's go back to the step where you chose your 10 papers, right? Once you've selected them, it's time to read them thoroughly, right? Dive into the introductions, the motivations, the design sections, right? The implementation, tables, figures, implementation details, evaluation, and so on, right? Can you understand at least 50% of it? Can you follow the logical flow at a high level, right? If this is your first time reading an entire research paper, brace yourself because it might take 8 to 10 hours to get through just one paper. I remember the first full paper my advisor assigned to me. It was exactly like this: 12 pages, 2 columns, 10-point font, 1-inch margins. Very, very dense. It took me an entire day to truly digest one paper. But once you get through one paper, ask yourself, or the 10 papers, ask yourself 3 crucial questions. First, can you understand it? Second, do you love it? Do you want to marry the paper? Right? And third, can you contribute to the research area? Because this is not just about taking another class, this is research. Do you enjoy going deeper and deeper into this topic? Do you find yourself getting excited about the intricate details of the papers? Can you see yourself immersing in this subject for years to come? Most importantly, do you believe you will be able to contribute to this area? This is a key distinction. Back in undergrads, I enjoyed algorithms, but I wasn't confident enough that I could make meaningful contributions in that field, and that's why I leaned towards systems instead. So again, will you be able to contribute in this research topic? Remember that as a researcher, your role is to invent, to innovate, to push the boundaries of knowledge. There's a huge difference between reading and creating, between knowing and building, between understanding and innovating. So let's recap. First, play the game of elimination. Then expand your knowledge like a spy, gathering a lot of intelligence, a lot of information. Finally, narrow your focus and make a decisive choice, just like a leader making a critical decision. This is the method I recommend, but if you have other approaches, I would love to hear them. Drop your thoughts in the comments, and I'll see you next time.